Okay, so here is the key for your review sheet. Please feel free to pause, fast forward, or rewind to any section that you may need. So here we're matching slope fields with their differential equation. So what's important is to look for when you have a zero slope, because that means you'll have horizontal lines. Look for where your function is undefined, because that's where you'll have no slope, and there should be nothing there or a vertical tangent line. And then notice where your slopes are positive and negative. So if I look at 1, I have 2x plus 2. Here I know when x equals -1, I'm going to have a zero slope. So when I look through all of my slope fields, I see here when x is -1, I have all these horizontal tangents. But then just to be sure, I also notice that this is all about x, and we're adding 2 and multiplying 2. So when x is positive, I know I will have all positive slopes. So to the right of my y-axis, I have all positive slopes. So this looks like a good choice for 1. When I look at 2, I have x minus y. So that means when x and y are the same value, I'll have a zero slope. So those horizontal tangent lines again. So now I'm looking for where the line y equals x is, where I have all those horizontal tangents. And I notice that right here, all along y equals x, I have my horizontal tangents. No other graph shows that. So this looks like a good choice for 2. For 3, I just have y. There's no x's here. So I know everywhere above the x-axis should be a positive slope, and everywhere below the x-axis where y is negative should be a negative slope. And when I look at all my choices, only one of them fits that, and that's right here. All above x, they're all positive. All below x, they're negative. When dy over dx equals cosine of x, I like to look to see if I can map out that curve, the cosine curve. So here, this one we already used. This one, clearly I cannot map it out. I have something going on up and down. Here, this looks more like a V. Over here, well, we used this one already. This one, something's going on over here, so no. But look here. I go down, I go up, I come down. This looks just like cosine. But just to be sure, let's look at this one. Here I'm going up, but I seem to be leveling off. So F look more like cosine. We used this one already. This guy looks like a parabola. This is a parabola, so no good. And here I'm going up. Oh, but look, I have all these horizontal tangents. So yes, F must be 4. Number 5, I have ln of x minus 1. Here I know ln of 1 is 0. So I know when x is 2, I'll have those horizontal tangents. So I look for all my choices there. The only one down here, look, I have all my horizontal tangents where x is 2. So this one is choice 5. Let's save this one for last, because this one is easier. Here it's all about x, and I know when x is 2, this guy is undefined. I also know when x is 0, I will have horizontal tangents. So I'm looking for the graph that has, oh, look here, vertical tangent line, undefined at 2, and through the y-axis I have all these horizontal tangents. So E goes with 7. This one is easy to notice also because I know when y is 1, I'll get 0, so I'll have horizontal tangents. Or when y is -3, I'll also get I'll get 0, so I'll have horizontal tangents. Well, that matches here. See, I have y above here, y equals 1, and down here, y equals -3, so 8 goes with B. Now I'm left with these two, 6 and 9. So when I look at these, then there were 3 graphs left. Well, this guy, we already said this guy looks like a parabola. None of these, if I integrate them, will be parabolas, right? I would need just x to get x squared over 2. So I know this is not an option for any of them. So I'm comparing what was left. G and C was left, right? I'm comparing these two. So let's see. This guy, I know this is 1 over the cube root of x. And so I know when x is 8, I'll have 1/2. In fact, when x is any positive number, I will have a positive slope. When x is any negative number, like -8, I'll have -1 over 2. There's no y's here. So wherever x is positive, I should have a positive slope. Wherever x is negative, I should have a negative slope. So when I compare these last two slope fields, look at this guy. Everywhere to the right of the y-axis where x is positive, I have positive slopes. And everywhere to the left of the y-axis, I have negative slopes. Therefore, this is 9. Okay, so now let's look at number 10. Number 10, we have dy over dt equals -2y. And if y is 1, then t is 0. What is the value of t when y is 1/2? So first thing we're going to do is separate. Make sure you get the y over here. I left the -2 here. And then I can integrate. I know when y is 1, t is 0, so ln of 1 equals c. And then when I put this into exponential form, e raised to the -2t, c is 0, so I don't have to write it, equals y. So here's my function here. But when y is 1/2, I plugged in, I need to find t. So if I log both sides, I end up getting ln of 1/2 equals -2t. I divide that over, I get -2. And so here is what I get. But it doesn't seem to match any of these. So I need to remember something about this. If I have ln of 1/2, I'm just rewriting this up here, can I rewrite 1/2 as 2 to the -1? Right, when I have a negative, this just means 1/2. Just like x to the -1 is 1 over x, 2 to the -1 is 1 over 2. And by laws of logs, if I have an exponent, I can bring it to the front. So this guy equals -1 ln of 2, and it's still over -2. Well, a negative and a negative equals a positive. It's a little tricky here. But again, that's why you need to know your rules for logs. Okay, so now number 11. Which of the following is the solution to the differential equation? And they give us this initial condition, y of 3 equals -2. So first things first, let's separate to integrate. So here I go, I integrated. And I know when y is -2, x is 3. And so I plug in here. So I plug in -2, I get +4. I solve this out, I get -7 equals c. So now from here, I plugged in, I multiplied by 2. So I multiplied by 2, this was -7, I multiplied by 2 to get -14. At 3, -2. When I square root it, since this is negative, this is negative. Right here I would get plus or minus the square root of this. But it's at a particular point, and this particular point is when y is negative, so it's just a negative answer. Number 12, we're going back, some old stuff. An object traveling in a straight line has a position at x of t. They give us the initial position, they give me the velocity function, and they want to know what is the position of the object at time equal 3. Well, if we're looking for a position, we need to go back. We need to integrate velocity. But they tell me the initial position at 0 is 2. So it's 2 plus, and we're looking for from after 3, whatever it is, 3 seconds, 3 minutes, whatever it is, of the velocity. So this is a calculated question because look at your answers, they're decimal. So 2 plus in your calculated 0 to 3 of this function will give me the position. Remember, if we used absolute value, that would be my total distance traveled. But if we want our net change or just position, we just integrate. 13, we're looking to find the derivative for a, b, and c. So here we have a triple. It's cos of x squared, and that cos x squared is being raised to the third. 1, 2, 3. So inside is x squared, 2x, times cos of something is negative sine of something. And then something being raised to the third power, 3 times that something to the second power. Then I just put it all together. 2x times 3, negative 6x. And that's it. B, it's a product. I have 2e to the 2x. Right? I have an exponential times the power function. So I draw my cross. This here is chain rule because this is not just e to the x, it's 2x. So I bring so derivative of 2x is 2. So that's 2 times 2 is 4. And then e to the something is e to the something. X cubed, 3x squared. This times this plus this times this. We get this guy. You might have it in the reverse order. If it's free response, you can leave it like this. However, it's a good idea on your own to find a GCF and make sure you know what it looks like if you factor this. So either answer is good. Here, again, we're looking for the derivative. So if this whole function is a, what is a prime? Well, derivative and integrals cancel. That means this function does not change. But it is chain rule because this is not just x, it's x cubed. So x cubed becomes 3x squared. Sine t squared, wherever I see a t, I'm plugging in x cubed and it's being squared. Minus derivative of radical x, 1/2 x to the negative 1/2. And then sine of, again, wherever I see a t, it's radical x and it's being squared. You can leave it like this, or you can simplify. 14. I think we've seen this one before. But remember, limits at infinity is the same as end behavior. An exponential function grows much faster than a power function. So this is bottom heavy. Bottom heavy is 0. 15 is a little tricky if you can use your calculator. This happens to be in the no calculator section of an AP exam. And so I analyze the numerator and the denominator. So you have to remember something about your functions. 5 plus 2 to the x, well I know 2 to the x is exponential, but it's going up 5. So if I look at this guy, I know this levels off at y equals 5, so I have a horizontal asymptote at y equals 5. This is in the denominator. So this is really 2 to the negative x. Right? 1 minus 2 to the negative x. So it's creeping up like this. Right? 2 to the negative x. If we brought this above, you could think of this as 1/2 x, but it's a reflection over the, right? This negative means it reflects over the x-axis. So this is what this guy looks like. And so, because we went up, I know it's y equals negative 1. I mean down, sorry, we're down. So this is leveling off below the x-axis. So, again, you knew for sure that this had to be y equals 5. So, but there had to be another one here. So even if you just knew the top, by process of elimination, you should have known this is y equals 5, and there had to be another one here. So no, no, and no. Has to be this, because you knew this was true and there had to be another one. So that's another way. Think of process of elimination. Number 16. So we have a slope field, and they give us this function, and they tell us g of x is a solution, right? Solution would be whatever we can map out of this with this initial condition. And they want to know the limit at this point. So I went over and I kind of figured out where negative 2, negative 1 was, and it's around here somewhere. And as it goes to infinity. Well, if I follow along this curve, look what's happening. It's leveling off here. Leveling off, so it's approaching 0. So kind of just map it out at the point given to you. 17. So I sketched my slope field. This was a pretty easy one, so I didn't write it out. I know when y is 0, I have horizontal tangents. When x is 0, I have horizontal tangents. When x is positive and I'm above the x-axis, these are positive. When x is negative and I'm above the x-axis, these guys are negative. So this is pretty easy to graph or sketch. Find the slope of the line tangent to the graph at the point 0, 1. Well, I just plug it in, I get 0. But I could also even see here, 0, 1. It's my horizontal tangent. It's 0. So two different ways to figure this out. Find the particular solution. Well, here we separate and integrate. This one was, again, easy because we get c equals 0. And so this is just my particular solution. Then it asks me, does f have a relative min or max or neither at x equals 0? Well, at x equals 0, f prime equals 0, so it's a critical point. Right? I know that because, again, if I go back, even to this graph, I have a 0 slope. So f prime is 0 when x is 0. And if I look, even just using this, if I look to the left, it's negative. I look to the right, it's positive. Oh, I have a relative min. I can even map it out. I see that relative min. And so that's all we really have to say. It's a critical point. To the left is negative, to the right is positive, and so we have a relative min. And for the particular solution, find the limit. Well, we know the particular solution is an exponential function, and so we know this continues to increase. So it's going to infinity. Technically, you could have said does not exist since it's going to infinity. Either one would be appropriate, infinity or does not exist. Infinity is a little bit more descriptive because my graph is going up. Number 18. A rumor spreads among a population of n people at a rate proportional to the product of the number of people who have heard the rumor and the number of people who have not heard the rumor. If P denotes the number of people who have heard the rumor, which of the following differential equations could be used to model this situation? Well, if P are the people who have heard the rumor, then n minus P, right, the whole population minus those who heard it, are the people who have not heard the rumor. It said the product. So I have P times n minus P, that's my product. K is my constant. Therefore, it's choice B. Remember, something proportional, y equals kx. This is when something is proportional. So we're just kind of really plugging that into this. Here's my k, here's my product. Here's my choice. I hope this is helpful. Please study, know all your derivative and integral rules, and practice identifying slope fields. Good luck.